Hello, welcome. Thanks for mapping with us today. Today you'll be participating in a Missing Maps Mapathon.
Back in 2014, the American Red Cross joined with the British Red Cross, Doctors Without Borders, and HOT, the Humanitarian OpenStreetMap team, to form the Missing Maps Partnership. Since then, we've grown to include about 16 global NGOs.
Over the last 5 years, 70,000 people all around the world have contributed to the project by adding data to OpenStreetMap, or OSM. At these events, mappers remotely trace satellite imagery to add features like buildings and roads to the map. OSM currently has about 1 million contributors, and 15% of those mappers contribute to humanitarian projects. So, you're probably thinking, hey, can't recent advances in technology help us do this more efficiently?
Yes,
Yes!
we've really enjoyed growing with new tools like machine learning and AI. When it comes to machine learning, current algorithms aren't advanced enough to be used in disaster response on its own.
We'll get there one day, but in the meantime, groups like the American Red Cross are working with those developing these new technologies. Instead of waiting for a final product, when we work together, these new and developing algorithms can be used to identify features that can help humanitarians in their work.
So today's event will be a bit different from the majority of our mapathons.
Today you'll be identifying only very specific features and adding those to OSM. You will be producing the dataset that the machine learning algorithm will use as a comparison so that it can get better at recognizing this feature. The more examples we give, the better the algorithm gets. This will allow our contributions to scale up and up and up as the machine gets smarter.
Machine learning is changing how we create data, but the human eye is still the top tool in our tool belt, so go map.
From all of us here at the American Red Cross, thank you for your time and happy mapping!
Today we'll be focusing on mapping bridges in Uganda.
We'll talk over some tips and tricks, but please see this guide for more detailed information. How do we recognize a bridge in OSM?
Let's look at a couple of examples. One easy way to find a bridge is to check intersections of roads and waterways. According to the OSM wiki, bridges start and end where they join solid ground. There can be multiple supports and spans, but for our purposes, a bridge should be one section of the road.
Here we have another example, this time at the waterways intersection with a smaller, unclassified road.
In Uganda, where they have a rainy season, you might find a bridge going over a dry riverbed. It will just depend on the season the imagery was taken.
Larger wetlands will be a bit more tricky. Here we have a long bridge over a wetland area and other roads.
Another tip is to look for shadows. This will help to define the existence and extent. Larger roads, both primary and secondary, are more in the open, and it is often easier to see the bridge. Residential areas are a bit more difficult as tree coverage can block your view.
If waterways aren't already mapped, you can recognize these features because they'll usually have more twists and turns than a roadway.
Overpasses are treated the same way as bridges over waterways.
In ID Editor, zoom in close so you can see the bridge more clearly. Double-click to add points on the highway or road at each end of the bridge. Next, select one of the points, right-click on the point, and select Split. Repeat with the other new point.
Then select the center section, the bridge span, and in the Edit panel on the left, select the feature, type of road, scroll down to Structure Options and select Bridge. You should now see black edges on the sides of the bridge span.
Thank you so much for your time. Happy mapping!